Welcome back to the workshop. Today I'm going to be starting a review. This is going to be a combined video over a number of days because I'm really excited about a newer product I received. A Secret Santa of mine was kind enough to send me the FrSky 80 amp ESC or speed controller, and I'm really excited about this for a number of reasons. One of them being all the telemetry goodies that you get along with it. And I mean, when telemetry first came out, I wasn't really a big supporter or excited about it because I'm like, well, what am I going to use that for? But it really is insightful in terms of trimming and properly setting up my radio and understanding flight times and things like that. So I think there are advantages and disadvantages. Obviously, the way that you fly is going to influence that, but I want to approach this speed controller from a fixed wing perspective, and today I'm going to start doing just that. One of the things that you need to know right up front is that this ESC is based on a BL Heli 32 platform. Those of you who aren't familiar with BL Heli, that's okay. Suffice it to say that the platform is basically derived out of the multicopter segment of the hobby, and that has a lot of things that we may not necessarily think about unless we sort of put things into context and do some comparisons. One of the things that I wanted to compare is that normal speed controllers that we get, we don't necessarily use like a flight controller to dictate the parameters. And a lot of times the BL Heli 32 ESCs are programmed through a flight controller. As a fixed wing pilot, I don't have any of that. So I've had to go out and see if I could find an adapter to connect this thing to my computer so that I can update firmware, change settings. There are no at the field programming cards that we're traditionally used to. There are far too many settings for that sort of thing. You have to use the BL Heli 32 suite that is downloaded and frequently updated, I might add. In the documentation for the BL Heli software, they do have schematics that are posted on the internet, and I'll insert a picture that's a close-up of this, but I do have an adapter that I have assembled and soldered. There are three things that you'll really need. One is a USB FTDI UART adapter thing. Usually you can find those things on Amazon or eBay for like $2 or $3. And then on top of that, you also need a Schottky diode and a resistor. And on the resistor, it's kind of specific what they have along with the Schottky diode, but I'll put direct links in the description for where and what part numbers I got mine. I usually get my parts from Mauser. So once you have this assembled, it's really a matter of following the proper procedure. You load up the software, you connect the speed controller to the USB adapter, and then you select the proper COM port, and once that's all hunky-dory, the software itself will actually tell you to power up the speed controller. So you have to physically connect the battery to it. Once you're in there, let's go over the features. Okay, so first I want to go over the normal stuff. The normal stuff is like low voltage cutoff and thermal protection, motor direction, Pwm frequency, timing adjustment, and then there are other things like brake, and the usual stuff is pretty much all in there. But the parameters are a bit broader than what you're used to. So I'm going to get into that. One last thing about connectivity: the Castle Link connector will not work. I tried, did not work. So make sure you build this USB adapter. All right, so one of the most comprehensive things you can adjust with this speed controller is your throttle settings. There are a lot of different things that dictate your control of the throttle, and one of the things that is sort of a nice feature about that this speed controller is how many steps are involved in the throttle range. So normal speed controllers, even high-end speed controllers, have less than 250 steps. The average speed controller, and I compared a whole bunch of standard ones and cheap ones and not so cheap ones and did a whole bunch of digging, it's around 100 steps. So quite a bit, but BL Heli 32 takes it a step further. There are 2,048 steps, which gives you a lot of resolution. Now, granted that Spectrum transmitters and Futaba transmitters, they only have 2,048 steps, but like Jetty and my Horus and the Aurora 9X, those transmitters have twice that resolution. So 4096, 4096, I can add. And so on top of that, you have the ability to adjust your max throttle. So even on high-end ESCs like YEPs or YGEs or whatever, even the Castle controllers that I've used, when you go to throttle, you get to like 70-80%, and on some motors and prop setups, you get to that 70-80 and you run out of throttle. There's no more advancement the further you move the sticks. Now you can adjust some of this in your computer radio, but there's advantages to having it just set here and forget it. You don't have to necessarily tweak it. And there are additional things that help you along with that and further refine that linear throttle range. So because of the 2,048 steps, you're not going to be reducing by much, if any, your throttle resolution band throughout the whole range. So that is something to look forward to. The other thing that is really unique about the BL Heli 32 software is the Pwm frequency. Usually it's in a trapezoidal sine wave. So pretty much the sine wave goes up, it goes over, it goes down, it goes over, it goes up. So it's in these trapezoids, and they have a setting called sine modulation mode. And really this is more for efficiency. It sort of rounds off those corners a bit more. And they go into specific details, not going to cover those here, but it's supposed to smooth out, make the throttle movement or pulses less jerky. So rather than having a basic on-off state for each of the pulses, it's slightly getting to max power and then full power and then not so max power and then back down. So you have quieter operation, less jerk, less vibration, things like that, and supposed to make it more efficient. Don't know, might not. So before we go any further, it's worth addressing sort of this elephant in the room. There's, I don't want to get too technical here, but there's a difference between something called RPM, which is, revolutions of a prop per minute, and then there's electrical RPM. So these speed controllers have different phases that they send pulses to the motor to energize the different poles, and that's what makes it rotate. So BL Heli 32 does have limitations in the amount of electrical RPM it can support. There's math that's involved here, but the average electric setup is going to be just fine. I did math for E-Flight Power 60, which would be an appropriate size motor for this 80 amp ESC, and that's around 83,000 electrical RPM. Now the max is like 280 to 300,000 electrical RPM on the speed controller at like the highest levels of whatever. Obviously it can go higher. I think other math demonstrated goes up to like 500,000, but yeah, 83,000 is, yeah, you're good. So a Turnigy SK3 5055 320 kV, and that's swinging on the airplane I'm going to be using, which is my Curtiss Hawk, is swinging an 1812 Zor prop and runs on a 6L. And the electrical RPM for that is 151,000 electrical RPM. So well within range. Everything is going to be normal. When you get into like the super high, crazy stuff, speed demon kinds of things, pylon racing applications, that's when you're going to really want to sit down with a calculator and go over the math to make sure that these ESCs will support it. Previously I mentioned that there is a mode called braking and within the braking there is a range that you can do. It's not just on or off. It can go from 1 to 100% brake. In addition to that level of braking where there's pulses holding the motor still or providing a back force to stop rotation, you have something called damped light mode. And what damped light mode is basically regenerative braking like you have on an electric car where it sends current back through. And what's nice about this is that it is a more controlled way to brake the prop rather than pulling energy and straining your battery or your speed controller. You're getting some of that energy back, obviously not all of it, and there's going to be efficiency losses. And there are some notable voltage spikes, so I would use it with caution in some applications. What they are, I'm not entirely sure, but in a low kV situation, you're probably going to have quite a bit of loss there. However, the application for this is something that I try to wrap my brain about. I have a bunch of guys in my club who fly iMac. And one of the things that they have to do are these downlines. And when you go in a downline, you have to control your speed, not just your angle and your wings level and stuff. So this is one of those situations that I'm like, aha, because when you pull the throttle off on any normal ESC, it just actively freewheels and you will accelerate through a dive. On gas and nitro, internal combustion engines, you don't have that active freewheeling. It just spins and spins and spins, and the air, as you accelerate, pushes the propeller faster and faster. So the propeller doesn't act like an air brake in those situations. You can do that. Now, it only works when you have the throttle set to 0. But going back to another throttle setting, as you come out of that dive, we have instant torque and instant RPM from these. It's not going to be much of an issue to transition out of that, but there will be a learning curve. The other application is in scale flight with dive bombers or any kind of bombing or any kind of like attack runs or things like that. You can control your dives. My SBD Dauntless has scale split flaps, and even with those split flaps open, it still accelerates on a dive because it's like a 12-14 pound airplane and the weight carries through, and yeah, it's really difficult to control that rate of descent. So that is another thing that you can use that for. Really, really awesome feature that I think a lot of people should be thinking about because it will help you have better flight experience. So there's another feature called Demag Compensation. So obviously whenever an electrical current is applied to a wire, it creates an electromagnetic field. We capture that in the iron stators that are in our motors. And when the electrical signal is turned off, it takes a while for that energy to dissipate. So with larger kV motors that this would typically be used with, you're going to have a larger amount of that potential energy. So by having demag compensation on, it helps to compensate for those de-energization losses or tendencies to desync from the speed controller. So it's to help alleviate stutters as well on spool up, but you know it's just one of those features that you wouldn't really think about. Because you know we're not too worried about spool up. However, you know when you're coming out of dives, having a more synced up acceleration, you can really do more controlled maneuvers, and you're not going to be forcing as much torque back into the airplane and then have to compensate for that. So again, this is sort of like a behind the scenes in the back of your head kind of thing that turn it on, set it, forget it. I think it'll do some neat things. One of the features that I love is being able to adjust the volume of the startup music. I hate how loud or soft some speed controllers are. So I have a speed controller that's really, really soft, and then I have other speed controllers that are just so loud and so obnoxious. It's like, yes, we have power! And it's like, okay, great, that's fine. The whole field doesn't need to know. But thank you for adding this feature. Oh my gosh, it has been far too long. Alright, so there are a number of protections that this speed controller features because of the BL Heli 32 design. So there is low RPM power. So when you're at lower RPMs, it can lower power. There is actual wording here, and I'm going to quote, "There's risk of toasting something if it's disabled." Just leave it enabled. It'll be fine. But you know, for lower kV motors, such as the one I'm going to try this out on, it could be necessary to disable on low kV motors on low cell counts. So there's less risk there. And this is directly from the manual. So probably won't use it on my airplane. However, there are situations like this, like World War I models, where you want large diameter, small pitch, so that you get lots of thrust. So say you have like a 20 by 6 and you're running it on a low kV and 3 cell. You're going to get loads and loads of thrust because that's what World War I airplanes need. And sometimes you can run into desynchronization issues if you have too much power at your lower RPMs to just get the motor running. It has a low voltage protection. It's basically the same as your normal low voltage cutoff. It protects it from over discharging the battery. There's current protection, but it's more like a current limiter so that you don't overcurrent, you don't draw more current and toast your ESC. Maybe it's just a safeguard. I don't know if there's really any true application for this other than just like trying to protect your investment. But it seems to me if you do proper math, you wouldn't need this feature either, but you know, to each their own, I guess. It also supports LEDs. The manual says up to 4 LEDs can be turned on or off. Don't know how, don't know what that means. I haven't been able to find any information on how to do this. There you have it. You can have Night Flyer support with the built-in speed controller. Obviously there are the telemetry issues. Okay, so you have ESC temperature, you have supply voltage, and you have a RPM sensor that all sends telemetry back to your radio. You can log all of this data using the FrSky OpenTX, but the caveat is you really need to have OpenTX version 2.2.2. This is new technology. You do need to have the latest and greatest softwares to support it. If you have OpenTX 2.2.1, you can run into issues where you have to set values or mathematical things in your radio to get the right readings. Now, with that said, there are also current readings from the telemetry, but that's all mathematically derived, as well as current use, current depletion, so you know how much is left in your battery. Again, it's all mathematically derived. It's not an actual sensor, so be aware of that. And you know, it's more or less a gauge for you. You don't necessarily need to have absolute accurate information. As a fixed-wing pilot, I'm not planning on flying any FPV. I don't fly FPVs, so I wouldn't need it on a heads-up display anyway. But nevertheless, it is there. One of the other topics that I've come across in forums and other areas of the interwebs is what does the future hold for this particular speed controller? And 2 points have really been brought up. There should be a 60 amp and even a 150 amp or 100 amp speed control versions. Yeah, I can see the high voltage ones. The 60, yeah, I can see that for like park flyer kinds of things. But really what kind of made me really wanting is that there's only a 3 amp BEC on this speed controller. The ESC that I'm swapping this out for to test on this has a 5 amp BEC. Now, this airplane only has 4 Futaba S3010 servos in it, so it's not going to be drawing that much current anyway. But if you're going to be going to a higher quality, high-end model that you're going to be using this in, you really want that telemetry, you're going to want more current for your nicer servos, whether they be digital or just bigger. Higher torque servos just require more power. That's just the way life is. That's the way the laws of physics are. Then there's the trade-off and the argument that people make, say, well, that's a balancing act, because if you're going to be doing a nicer model, you're going to want a dedicated BEC that's separate from that electrical system anyway, just for redundancy and safety. And I can see that argument too. I could go both ways on this. I've been flying with this particular speed controller. It's a Turnigy. It's an 85 amp, has 5 amp BEC, and I've been flying with it for years. Has never failed me. And I've never felt a need for a redundant BEC on this airplane, which is a giant scale airplane. There you go. Last, before I get into any kind of application, is there are some grains of salt that you have to take with this. This is a new product. It's still new. I know people think that technology in this hobby just goes crazy, crazy fast, and it does, but this was released in April of this year, and it has gone through a lot of teething issues. There have been firmware revisions, and on that note, you really should go to the FrSky website and download the firmware, the latest firmware for this speed controller, and then you put it into the BL Heli software firmware folder. That way the software can have access to it and you can write the firmware. You cannot write the firmware to the speed controller like any other telemetry module that FrSky offers. You can't do that from like my Horus radio. I can flash the receivers through my radio. You can't do that with this. Make sure that all your software and your firmware is completely up to date, and you have to understand that there are going to be things that are still being worked on. So with that said, BL Heli is this primarily focused on multicopters, and so a lot of these functions come from that. Like you can change direction, sure, but there's bidirectional modes, so you can have the prop spin fully front ways or back ways. You could apply this to fixed wing for like indoor flying, just rather than have one of those fancy variable pitch prop setups on the front of you could just use one of these. There's a lot of different applications for this stuff, and I think that fixed wing pilots are glossing over it because they're, that's multicopter technology. BL Heli stems from tinkerers. It is really guys in the hobby driving this, and BL Heli 32 is their latest iteration that is now closed source. Everything up to this has been open source, and they've put a lot of effort into it. Clearly, they've put a lot of effort into this design, and I don't have a problem supporting them monetarily for that. I think people should. When you have a good product, when you have a good idea, you should be compensated for it. So with that said, I am going to put this speed controller in that airplane, and then I'm going to come back and I'm going to give some of my thoughts and impressions. So let's get flying. Alright, so to wrap up how I generally feel about the FrSky 80 amp speed controller that's based on the BL Heli 32 software and architecture, I have to say that it works just fine. I will say also that compared to the other speed controller that I've been flying for years on this airplane as well as other airplanes, that when throttling down, the throttle down is more abrupt. And also the brake, when you go to 0, it does have an effect. Obviously, I didn't have all summer long to adjust and tweak and make changes so that it's at its optimal, but it does work. It does slow it down, and what's kind of strange too is that I realize that when I'm landing, not just looking at the airplane and what it's doing, I'm also paying attention to the sound that the airplane is making.
So the first time that I landed and I had the throttle set to 0, it made a slightly different noise than I'm used to, and it kind of threw me off, and my landing wasn't perfect. So I'm not showing you any flight footage because that's not how I normally fly. But I will say that everything is just absolutely fun to play with and tweak. And I think it really is worth having a serious look at if you are a precision pilot or a scale pilot, because there are some features that could be useful for you. I know that they're going to be useful for me as a scale pilot. I did have a chance to have a chat with my other club buddies at the field who fly IMAC, and they corrected me. I was wrong. They are not judged based on the speed of their downline. Mostly it's about angle and being able to maintain the proper angle on their downlines. They said that generally it is sort of a benefit, an added benefit of gas engines, that they are able to better control their downlines and anticipate where they're going to be a little bit better because the acceleration is not there. So they said, well, it's just something I never thought about. And, you know, as an electric pilot, I can see why that might be an advantage. So again, take things with some salt. And, you know, I had some problems trying to get things to connect because I'm new with the BL Heli. And, you know, it's really quite simple. So needless to say, once you get your head around how the BL Heli software works, how you're supposed to make connections, how to do the programming, things are quite easy. With anything new, there's a learning curve. And with that learning curve comes a little bit of frustration, and that's okay. Know that that's normal, and know that there's a plethora of help out there. There's entire forum threads on RC groups. I know there are a couple on the flight test forum groups. I believe that there are a couple that I've come across on Wattflyer. So, you know, there's some learning curve, there's help, and most of all, the experimentation is phenomenal. There's so many wonderful things you can do with it. So I am actually going to give it a high recommendation, but I am going to give it a caveat. I will note that the voltage that was supplied was not 5 volts coming out of the BEC from the speed controller for my receiver. It was 4.8. With that in a larger airplane, I wasn't able to do a whole lot of maneuvers because I don't have as much voltage. Normally the BEC that I have in it supplies 6 volts. So more voltage means speedier servo response, as well as stronger servos, so you can really bang on the sticks more and do more of those 3D maneuvers without risking a servo failing or overcurrent the system. You know, it's only got 3 amps that it can supply. But I was a little disappointed that when I hooked it up to telemetry, the telemetry was reading it at 4.8 volts, and I did verify that by voltmeter. So definitely need to look into that spec, because I mean, most servos can handle 5.5 volts easy, if not 6. Some of the higher voltage servos do start at 7, but you know, if you're going that way, you're going with an external controller, no doubt. Because those servos are not cheap, and that's just an added bit of precaution for that investment. So with that said, all of this said, this is a long video, and I do apologize for that, but it is comprehensive, and I love to approach these things from a fixed wing pilot perspective, because we just don't get those in a lot of this new technology. It's always about the multicopter and the quadcopter and the tricopter and the whatever copter, and I just think that so much of this stuff can be applied, but sometimes it takes a little bit of out-of-the-box thinking. Maybe you got inspired by some of the stuff that I've shared with you on this video. If you do, please leave it in the comment section below so that other people can see your great ideas. And with that, I'm Joshua Orchard, and thank you for stopping by the workshop and listening to me rant for a little bit.